is the final question in this paper. It's question 11, and it's from the 2023 A2 Pure Maths paper from CCEA. It was sat on Tuesday, the 6th of June. So let's take a wee look. There's two parts here. Part A is then going to be an integration question. So find the exact value of sine x plus cos x all squared integrated between pi over 6 and 0. So first of all, I'm going to multiply this out and see what we end up with. So it's between pi over 6 and 0, and that's going to give me sine squared x plus 2 sine x cos x plus cos squared x. It's actually not as bad as it looks. There's a couple of different ways of kind of tidying this up. Sine squared plus cos squared is just 1, which is incredibly handy. So it's 1, and then we can rewrite this. You can do it a couple of different ways, but 2 sine x cos x is just simply the sine double angle formula. So it's sine 2x dx, and we need to then kind of integrate this. And the reason I'm doing it, changing to this, is obviously this is much easier to integrate than this. It's still very doable this way, but it would give us then the correct answer. So we can now at a stage where we can integrate. So that 1 turns into an x, and then integrating sine goes to minus cos, and because it's the 2, then it's going to be minus a half cos 2x, and that then is between pi over 6 and 0. So subbing in the pi over 6, I obviously get pi over 6 here. Take away a half. So pi over 6 in times 2 gives me pi over 3, and cos pi over 3 is then actually just a half. Then take away the 0. And remember, cos of 0 isn't 0, so cos of 0 is going to be 1, I think, isn't it? And then half of that, so we're going to have minus a half. So that gives us pi over 6 minus a quarter plus a half, and that gives us then pi over 6, no, plus a quarter, because minus a quarter then plus a half gives us that. On then to part B. So again, another bit of integration here. I think they're asking us to find the area between the two curves. So the graphs of the function x ln x, and then we have this of x plus 1. Find the exact value of the shaded area. So it's between this one and this one. Now notice the g of x1 here is the one bit that's on the top, and it's between 1 and 3. So we're going to have to do the g of x minus the f of x, and we're integrating them between 3 and 1. So let's set it up with that. So it's the integral between 3 and 1 of g of x minus f of x dx. That means it's the integral between 3 and 1 of, so the g of x is the x plus 1, so it's x plus 1, take away x ln x dx. And this one here we generally do by integration by parts. So let's take a look then at what we're going to do here. So I'm going to take this over then to the other side, and we'll sort of do it out separately here, but the x ln x then is one I guess you should have sort of seen before, but we'll do it over on the other side. Give me a second. So I've just written this, just the same thing, just at the top then of the new page, and let's see where we're going to go. So I'm actually just going to take this wee bit off to the side. Maybe not the tidiest thing to do, but work out the integral of x ln x. So this is the one where we're going to get u is ln x, and dv by dx, I'm using integration by parts here, is equal to x. Du by dx, if you differentiate ln x, you of course get 1 over x, and then v is a half x squared. So my formula for the integration by parts is uv, so it's a half x squared ln x minus the integral of v du by dx. So that's 1 over x times a half x squared. So that cancels one of my x's, so it's just going to give me a half x. So that gives me a half x squared ln x minus, add 1 to the power, divide by the new power, a quarter x squared. There is the plus c in there, but because we're doing definite integration, we can have that. That means this, whenever we integrate it, is going to turn into a half x squared plus x, take away, and again, as I said, it's a half x squared ln x minus a quarter x squared, and that's between 3 and 1. So just to tidy this up a wee bit and guess, kind of get rid of my minuses, it's going to be a half x squared plus x minus a half x squared ln x plus a quarter x squared, and as I say, that's between 3 and 1, and they want the exact value, so let's again work through our sums in from here. So nice and slowly, 3 substituted in, that's going to be 9 over 2 plus 3 minus a half upon 9 upon ln 3, and 3 squared, and that's plus 9 over 4. If I then substitute in the 1, that gives me a half plus 1. That's going to be ln 1. That's actually just going to disappear. So it's going to be minus a half upon 1 upon ln 1, and then plus a quarter. And we have that. Let's see if I can start to tidy this up a little bit. You'll probably just want to use your calculator for this, but I don't really like doing that, so I'm going to see if you can see what I'm going to do here. That 9 over 2, and then you take away 1 over 2, that gives me just then a 4. That 9 over 4, and you're taking away a quarter, that gives me then 8 over 4. So that actually turns into 4 and a 3 and a 2. So that's 9. I've used those 2, and then I've taken away 1. So it just, the numbers then kind of turn into an 8. Minus a half times 9 ln 3 is just minus 9 over 2 ln 3. And then this here, that 1 we've taken away, so we had 9 here, take away 1 gets the 8, and ln 1, again, try it in your calculator, it doesn't give you anything, so that's us all tidied up, and that's then square units. That's us finished.